Hello ladies and gentlemen, my name is Hartwig Künzel and I'm head of the Hygrothermics department at the Fraunhofer Institutes for Building Physics in Germany. Since over 30 years I'm doing research on the durability of building materials. To evaluate the long-term behavior of materials, we use mainly three different tools: free field measurements, tests in the laboratory, and numerical simulations. Today I will show you especially why we do field tests and how we do conduct them. Let's start. So why are we conducting free field measurements? In the 50s, outdoor testing was the only way to gain more insight in the hydrothermal performance of buildings and their components. Therefore, our outdoor test site was established close to the German Alps. There, 20 test buildings made of different materials were set up and examined. Investigations in these free field tests were so successful and the impact on the German construction sector was just judged to be very positive. And therefore, the originally provisional test site soon became a permanent part of the institute. In the following decades, more and more test buildings were added and the main research focus changed several times. Now we have also other methods to evaluate the durability, but we still need free field tests, for example, to verify if digital models really depict the reality. In addition, we discover peculiar characteristics of constructions in real tests that are not detectable in a simulation. In the meantime, of course, things look somewhat different here, but in fact, we are still carrying out numerous investigations into the durability of building materials in the field tests. Here you can see our experimental building for outdoor weathering. We conduct research there on wall elements and whole facades. Additionally, we do driving rain tests. With the data collected, we can make reliable assessments about materials. Our focus is primarily on durability, prevention of damage, and usability. For the driving rain test, we manually calibrate the water level and do ongoing documentation. At our own weather station, we do automated rain measurements and capture data on normal rain, driving rain, and drifting snow. We are measuring wind speed and direction as well as air humidity. Here you can see how we also measure the global radiation. We have been recording extensive weather data for around 70 years. These form an excellent basis for our tests and evaluations. The experimental building is air conditioned and we are recording the indoor climate at all times. By considering the indoor and the outdoor climate, our tests on wall structures are based on real conditions. Here you can see how we prepare wall elements for the investigation. We first install the brick masonry, mount the sensors to measure temperature and humidity, and finally also mount the internal insulation. With a forklift truck, the wall element is inserted into the facade of the test building and it stays there for anything up to 3 years. In this way, we can compare wall constructions and insulation systems and validate calculations and characteristic values. Afterwards, we remove the wall elements to measure humidity by gravity. Based on our calculations and the outer weathering results, we can recommend suitable measures to our partners. We also have the optimization of materials in mind. Now let's go back to our lighthouse project in INDORE. There we have a building made of concrete, which is inside and outside clad with calcium silicate panels. If we look at the climate data, we see that there are some months with very strong precipitation. That means that the outer layer, in this case the calcium silicate panels, have to withstand strong weathering. Calcium silicate boards are extremely interesting from the point of view of building physics. Therefore, we will now take a closer look at the material and its properties. This material is very capillary active insulation material. This means that due to its properties, the board is able to absorb and transfer any moisture that occurs. Thus, they can contribute to a stabilized moisture balance while insulating very well. This is why they are primarily used as interior insulation in Europe, especially in listed buildings where people are reluctant to use petroleum-based insulation materials, which are, of course, much cheaper. Exterior application is not common, but quite possible. However, it must be remembered that the board absorbs moisture from the outside and also transports it to the inside, to the concrete. Ideally, the moisture is also released again promptly, as shown schematically in the animation. It is questionable, however, how long the material will withstand this strong stress. This would have to be further investigated. 3 field tests, as shown on the right-hand side, could give the necessary information. In climates where frost sometimes occurs, this application should not be used at all, as the freeze-thaw cycles can lead to spalling. Therefore, when using this material outdoors, it makes sense to protect it with an additional covering layer. For example, water-repellent plaster. In this way, a critical amount of moisture does not penetrate into the structure, and the insulating value of the panel is also preserved. With that, I'd like to thank you for watching this video and say goodbye till next time.